This lesson is for Advanced Algebra, Lesson 11.4 on finding zeros. Keep in mind that sometimes they don't ask you to find a zero, they'll ask you to find any number of other things, but what they really mean is find a zero. So they could ask you to find a zero, or a root, or a solution, or an answer, or an x-intercept. Those all represent the same thing. Unfortunately, there's 1, 2, 3, 4, 5 different ways they could ask you to do the same thing. So just keep in mind that zeros are what our focus is for today. There are 3 ways you can find the zeros. The first way is to factor it and set each factor equal to 0. That is the first method I'd like you to try whenever you're asked to find zeros. You should always try to factor it first and then set the factors equal to 0, and we'll do a bunch of examples of those today. If you are unable to factor, your next avenue is to try to graph it. After you've graphed it, you need to identify where the x-intercepts are. Those x-intercepts are the zeros. There is a third way if graphing doesn't work for you, and that is to use algebra or the quadratic formula to solve. We're not going to get into that in this video. That'll be in a later part of chapter 11. So let's talk about setting the factors equal to 0. If you have a problem that you're solving and it's equal to 0, then in multiplication form, one of those numbers must be 0 then. So if you're doing a times b equals 0, then either a is 0 or b is 0. So to figure that out, we're going to set our factors equal to 0. Also, the factor theorem allows for the fact that when you factor, if you end up with x minus something as one of your factors, that number, when you plug it back into the polynomial as your variable, should generate the number 0. And so I'll be illustrating the factor theorem in several ways during the examples. First example says, solve 0 equals x squared plus 5x plus 6. Keep in mind that up until now, most of the time they would just give us a polynomial and ask us to factor. So now the question has changed. It's still a polynomial, but now it's set equal to 0 and they say solve. You're still going to try to factor it to try to get the solutions. To decide what kind of factoring you're going to use, we've talked about that in a previous lesson. Look at how big it is. See if it has any GCFs. First of all, there's no GCFs. Second of all, it's a trinomial. Once I've established it's a trinomial, I look at the leading coefficient. If the leading coefficient is a 1, I'm just going to do an x. The top of the x is this AC value, or the product of a times c, so in this case that's a 6, and the bottom of the x is the b value, in this case a 5. I look for factors of 6 that add up to 5. Those numbers are 2 and 3, so I write out my factors as x plus 2, x plus 3. Now, if those are equal to 0, then one of them must be the number 0. So I'm officially going to set each factor equal to 0 separately. But know that I'm going to show you a shortcut for this in just a moment. What plus 2 is 0? Well, isn't that negative 2? And what plus 3 is 0? Isn't that negative 3? So the zeros and the factors are typically going to be opposites of each other. So notice here in the factor theorem we've got x minus r, and r is the 0. Same thing happened here. We had x plus 2, so the opposite of that, negative 2, is the 0. If positive 3 is the factor, then negative 3 is the 0 that goes with it. So that's how the factor theorem works. The other way that it works is if you plug these zeros back in, you should get the number 0 in your polynomial. So let's just try that out real quickly. If I take negative 2 and square it, and do 5 times negative 2 and then add 6, I should get the number 0, because that's what the polynomial says. Negative 2 squared is 4. 4 plus negative 10 here when we multiply plus 6 is indeed equal to 0. Same thing happens when I try my negative 3, the other 0. If I square that, multiply it by 5 and add 6, I get 9 plus negative 15 plus 6, and that is also equal to 0. So the factor theorem is super simple and super useful. Let's continue on and try some more practice questions. Again, we're asked to solve. Our first job is to try to factor it and then set the factors equal to 0. Right away I can see that they all have an x and they all have at least the factor of 3. So I'm going to pull out a 3x. Then to find out what's left, I ask myself, 3x times what is 3x cubed? X squared. 3x times what is negative 33x squared? 11x. 3x times what is 90x? And that's 30. Now you should see if you can factor the part that's inside the parentheses any further. It's a trinomial with a leading coefficient of 1, so I should try to do the x method to see if I can factor it some more. The top of the x is the 30, the bottom of the x is the negative 11. Factors of 30 that add up to negative 11 are negative 5 and negative 6. So keep your GCF at the beginning, and then you're going to have x minus 5 and x minus 6 as your factors. Now set the factors equal to 0. Rather than writing out this step that we had done earlier, we can usually just do that step in our heads. 3 times what is 0? That's going to be 0. What minus 5 is 0? 5. And what minus 6 is 0? 6. I wouldn't have even needed to ask the question for these two because I know the factors and the zeros are opposites of each other. One more. Look for a GCF first. They both end in the number 0, so 10 is a common factor. I've got x to the 4th and x squared, so x squared is common to both. 10x squared times what is 10x to the 4th? X squared. 10x squared times what is negative 250x squared? Negative 25. Look and see if you can factor the part inside the parentheses any further. The part inside the parentheses is called difference of squares. It's going to factor into x plus and x minus, and then you just do the square root of the other number. So that's going to be 5 and 5. Don't forget the 10x squared drops down. So now we say 10 times what squared is 0? That has to be 0. Keep in mind that there's actually two of those because there's an x and another x there because it's squared. So there's two zeros. What minus 5 or what plus 5 is 0? That's got to be negative 5, and the opposite here is going to be positive 5. One other thing I want to point out here that we're finding the zeros, and the number of zeros you get should match with the degree. So we ended up with 3 zeros here, but one of those zeros is a repeat, so that ends up being 4 altogether. Same is true on the previous example. It was a degree 3 problem. There were 3 zeros. Degree 2 here, so we got 2 zeros. Let's try one more with factoring. This one's a little bit different. It's a trinomial with a leading coefficient of 1, but it's not a degree 2. So I'm going to just modify it for the moment and make it a degree 2, and I'm going to factor that instead. So factors of 45 that add up to negative 14 are negative 9 and negative 5. So I'm going to write x minus 9 and x minus 5, again equaling 0. But remember, we aren't doing x squared, we're doing x to the 4th. So what two numbers multiply to make x to the 4th? X squared and x squared. Keep in mind that we're actually going to factor now one more time on each of these because these are both going to be difference of squares as well. So this first chunk of parentheses I can factor into x plus and x minus. I'm going to do the same thing on the second set of parentheses, x plus and x minus. Now in the first set of parentheses I need the square root of the number, so that's going to be 3 and 3. On the second set of parentheses I don't know the square root of 5, so I just leave it as square root of 5 in both cases. Now I set each factor equal to 0. Basically I'm just going to take the opposite of each. So I get negative 3, positive 3, negative square root of 5, and positive square root of 5. So there's my 4 zeros, and I would expect to have 4 because the degree is 4. Another type of problem that students might encounter is one that's already been factored. Common mistake here is for kids to start to distribute, to try to get rid of the parentheses. Students are usually used to doing that. When they see parentheses, they think distributive property. But you don't want to do that on this one. So let's write a big note here for ourselves. Don't distribute. The good news here is it's already been factored, and once it's in factored form, then we can find the zeros. So write a note here, just find zeros. Now the number here in front doesn't have a variable next to it, so he's just going to sit there. I'm not going to set him equal to 0 because 5 doesn't equal 0. So the 5 just basically gets ignored. Then what minus 2 is 0? That's going to be a 2. What plus 9 is 0? That's going to be negative 9. And then the last one here, we can't just say -1 because there's a 3 sitting there. So we're going to actually set that one equal to 0 and then solve it. We didn't need to do that on these two because we could do those in our heads. To solve for x here, I would subtract 1 from both sides and then divide by 3. So I end up with -1/3. So now I've got 3 zeros, 2, -9, and -1/3. Another type of problem you might encounter is when they want you to go in reverse order. All the ones that we've done so far were in polynomial or factored form. We found the factors and then we set the factors equal to 0. So let me kind of write out those steps for you. So they gave us a polynomial, we factored it, and then we turned the factors into zeros. So there's kind of that 3-step process. On the one we just did, we started the process right here and we found the zeros just from the factored form. What we're going to do in question 6 here is go the other direction. They give us the zeros and we're going to turn them into factors and then turn that into a polynomial. So all you're going to do is remember that zeros and factors are opposites of each other. So just like on the previous question, x minus 2 was the factor that matched with a 0 of 2. So if 2 is the 0, the factor that it came from was x minus 2. Same thing with these fractions. Don't be freaked out by fractions. I'm going to show you a shortcut. If -7/2 is one of the zeros, then +7/2 is the factor that it came from. Same thing with the 1/4. If 1/4 is a 0, then x minus 1/4 is the factor that it came from. I don't like fractions very much. They tend to make things more complicated, and I tend to make more casual or careless mistakes when they're around. So to get rid of the fraction, just multiply that chunk by whatever the denominator is. So if I do 2 times x here, that's going to be 2x. 2 times 7 is actually 14, but divided by the 2 that was already there is still going to be a 7. Same thing here, I have a 4 on the bottom that I want to get rid of, so I'm going to multiply both chunks by a 4. So I end up with 4x. 4 divided by 4 is going to keep it as a -1. Now go ahead and use this problem as practice for expanded distributive property. We're going to multiply or FOIL the first two and then take the answer times the last one. So when you're all done multiplying the first two together, you end up with 8x squared plus 26x minus 7. Then I distributed that answer to the last chunk, the x minus 2, and I got 6 products there. Some of them were like terms. My final answer is here. So now the last thing we're going to look at is how to factor with graphing. Some polynomials are unable to be factored. Notice on this one there is a GCF that we can factor out ourselves, but then what would be left is a polynomial with 4 terms, and we don't really have a method for after the GCF. We don't have anything to do for a polynomial with 4 terms. We only work with binomials and trinomials at that point. So we have to factor it some other way. So we're going to factor by graphing. Our goal is to find those x-intercepts, because then we can turn those x-intercepts, also called zeros, into factors. So the first thing you're going to do is grab your calculator. You're going to start a calculator page and you're going to type in the polynomial. Go ahead and try that while you pause the video. Once you've done that, you'll see a very uninteresting graph. There'll be a couple of lines, and that would be graphed in your standard or default window. So we can see here that we've got a 0 happening at -9 and a 0 happening at 8. But we're hoping or expecting there to be 4 of them altogether. Notice that one of the factors, or one of the coefficients I should say, is a really big number, 1080. So the window that we're currently looking at is probably not large enough to see the full picture of the graph. So this part is fairly challenging. There's no way for me to tell you exactly how to find the right window because each question is different, but some things that you can try. Usually if you have a very large coefficient on the x, it's going to make your y values expand pretty greatly. So I would recommend changing the window settings for the y min and max to be much larger than what they currently are. Definitely go to a number beyond the numbers that you're working with. To modify the window, you go Menu, Window, and then window settings. You have the many different options there. The one that I would recommend is changing the X min and the X max. And usually I go to like 50 or 100 as kind of my first best guess. Then you change the Y min and the Y max. Leave the scales at auto or automatic. That'll make your life a lot easier. For the Y min and max, I would go to at least 2000 and negative 2000 to start with. And then if we need to expand or shrink, we can go from there. So I want students to know that you should try this a couple times on your own. Try to modify the window so you can see all 4 x-intercepts. This is not easy to do, to change the window, so it does take a little bit of perseverance on your part. Go ahead and give that a try while you pause the video. So the window that I ended up using was negative 20 to 20 for x and negative 5500 to 4500 for y. Then we can go through and find where exactly all of those intersects or x-intercepts occur. On mine, you can actually physically count the hashtags or the hash marks and figure out where they occur. They occur at 0, negative 9, 8, and 15. So let's turn that into factors, because that's what they originally wanted us to do. Remember that zeros and factors are always opposites of each other. So if I have a negative 9 for a 0, x plus 9 is going to be one of my factors. For 0, it doesn't really matter. It's going to be either x plus or minus 0. I like doing 0, or minus, excuse me. And then we've got x minus 8 and x minus 15. So that would be the factors that would go with this graph. Let me get into a little more detail on how you'd find these zeros. So for that, I'm going to go to my calculator. Once you've got it graphed and you've monkeyed around with the y and x intercepts, the y and x mins and maxes, then if you want the calculator to actually find where that occurs, you're going to go to Menu, Analyze Graph, and choose 0. It's going to ask you for the lower bound, so you're going to go to the left of wherever the 0 is and click in your center button. Now move over your cursor to the right and click somewhere to the right, and it tells you that it's occurring at negative 9. Since we have more to go here, we're going to do that process again. Menu, Analyze Graph, 0. This time I want to go a little bit to the left of the 0 and a little bit to the right of it, and you can tell that it's clearly at the origin. Let's do it again. Menu, Analyze Graph, 0. Now I'm going to go to the left and to the right of this 0, which was indeed at 8. Do it one final time. Menu, Analyze Graph, 0. Go to the left of the coordinate and then to the right of it, and it tells me it's at 15. And I can't see the rest there, so if you can move it, you can kind of grab it with the little hand symbol. So that number was at 15. Let's move it up there. And those were the numbers we anticipated them to be, but I wanted you to see how to actually find them on the calculator. So we had our zeros, we turned those into factors, and that's it.